The principle of phase contrast microscopy, simply explained. Phase contrast is by far the most frequently used technique in biological light microscopy. Living cells can be observed in their natural state using this simple and inexpensive method without causing any cell damage. Fixation and labeling are not necessary. But what makes phase contrast microscopy so special? Unstained living cells absorb practically no light, making them nearly invisible under a brightfield microscope. With phase contrast, structures that are nearly invisible with a brightfield microscope are revealed. To understand, let us have a quick look at a standard brightfield microscope. In a brightfield microscope, the lenses in the condenser focus the light on the sample, which is then collected by the objective and then projected to the camera chip or an eyepiece. When light passes through pigmented cells, like erythrocytes, it is highly absorbed. The high absorption reduces the light's amplitude, thereby decreasing its intensity. As a result, the absorption alone is sufficient to create a significant contrast between the pigmented cells and the surrounding medium, making pigmented cells visible under the microscope. Non-pigmented cells, however, absorb almost no light and cause only a slight phase shift, which is not sufficient to produce a clear contrast. This is where phase contrast microscopy helps. By introducing a phase ring, it adds a defined phase shift to the light not passing through the sample. This phase-shifted light then interferes with the light coming from the sample, enhancing the contrast and making low-contrast cells clearly visible. And this is how it works. The key components of a phase contrast microscope are an annular ring located in the condenser and a phase ring located in the back focal plane of the objective. The annular ring structures the light by creating a tube-shaped illumination that is focused on the sample. As explained earlier, the light not passing through the sample remains unaffected while keeping its tube-shaped structure. This allows a precise transfer through the phase ring where a defined phase shift is applied. However, the light passing through the sample undergoes a slight phase shift and becomes scattered. Due to this scattering, it loses its tube-shaped structure, and thereby most of this light bypasses the phase ring. Now, the light passing through the phase ring with defined phase shift interferes with the light coming from the sample, creating an interference pattern. This interference pattern leads to an altered amplitude and by this, to an increase in contrast, making the non-pigmented cells clearly visible. Therefore, it is crucial that the annular ring and the phase ring are well matched and precisely aligned to achieve maximum contrast. So, the basic principle of a phase contrast microscope is transforming a phase shift into an intensity shift to create a good contrast of non-pigmented cells. If you find this video helpful, please give us a like and subscribe to the ibidi channel.